Okay, so let's talk about AI. If you've recently tried to get, a straight answer from a chatbot, or maybe wrestled with one of those generative models that just confidently make stuff up, the hallucinations, you definitely know the frustration I'm talking about. You ask something clear, but the AI, it just seems to miss the point somehow. It's like it totally nailed the grammar, the structure, the syntax, sounds perfect. But it somehow completely missed the memo on the actual meaning, right?
That's exactly it. That's the core tension we're seeing. And it's not just like a minor bug. It points to a really deep, almost philosophical limitation in current AI. They are fantastic at the mechanics, the algorithms, the stats, predicting the next word, amazing stuff. But as our sources point out, they lack what you could call true interpretive activity. They struggle to ground the language they use in, well, real-world context, real meaning. So yeah, they can write beautiful sentences, but they don't really get why they're saying it or what it means for you, the user.
Right. So our mission in this deep dive is to explore a potential path forward, one that goes beyond just crunching numbers. We're going to look at how turning to philosophical hermeneutics, which is, the study of interpretation and context, might offer the framework we need to help AI evolve into systems that are genuinely meaning-aware. We'll be drawing on work from people like Gerardo Iòvane, Giovanni Iòvane, and others, bridging this gap between deep philosophy and AI design.
Absolutely. And to really grasp the solution, I think we first need to understand why the older approaches kind of hit a wall. Where did that dissatisfaction come from?
Okay, let's unpack that, starting with how people first thought about machine intelligence. For a long time, AI research was really guided by this idea called the physical symbol system hypothesis.
The classic approach.
Yeah, the basic idea was that intelligence is basically just manipulating symbols like numbers or words according to a set of fixed rules, which, okay, worked great for things like chess. But conversation, not so much.
Exactly, because that creates a system that's just too rigid, fundamentally too inflexible for how messy human language and interaction actually are. Sources like Dascal, way back in '89, were already pointing this out. If human understanding depends on context, and context is always shifting based on history, intention, the situation, then a static system, when based purely on fixed rules and symbol shuffling, it's always going to fall short. It can't achieve real hermeneutic understanding. It's just too brittle, as you said.
And you see that brittleness perfectly in some older AI, right? Like those chatbots built purely on rules. They rely on these fixed ontologies, these rigid taxonomies. It's kind of like having a library where every single concept has one specific unchanging label, like a Dewey Decimal Code.
That's a really good analogy. Those taxonomies, they're useful for storing information, sure.
Yep.
They really limit what the AI can do. Because if you ask about something that doesn't quite fit a predefined box, or if the meaning shifts mid-conversation, like you mentioned, talk about river banks versus financial banks.
The system breaks.
Right. The fixed ontology just can't handle it. It spits out irrelevant stuff because the context changed and its rules didn't. The design is inherently deeply context insensitive.
Okay, so that rigidity leads us right into the big issue with today's large language models, this hallucination problem. We know they can sound totally convincing, totally appropriate for the conversation, but be completely wrong factually.
And Largy and Daugherty, in 2023, they gave a really sharp definition for this. Hallucinations are contextually appropriate outputs that are not semantically accurate.
Contextually appropriate, but not semantically accurate. That's key.
Exactly. The output sounds right, the grammar's perfect, it fits the flow,
Yep.
but the meaning, it's just detached from reality.
Why does that happen? Why does the meaning just drift away like that?
Well, it's largely because these models work by predicting the next most statistically likely word or token. They're masters of linguistic patterns, of structure. But they lack that interpretive activity we talked about. There's no real internal mechanism for them to figure out the meaning tied to the user's input, like what did you actually intend, or even to understand the meaning of their own generated text. To get truly meaning-aware, AI needs to interpret intention, the history of the chat, the link to the user's specific world.
Okay, so if fixed rules are the problem, we need a different philosophy. One that embraces flexibility, change. And that seems to be where hermeneutics comes in, offering this idea of adaptive knowing or epistemology.
Precisely. Hermeneutic philosophy, drawing from thinkers like Gadamer, Heidegger, argues that real understanding isn't static. It's inherently context-dependent. It's adaptive. It is interpretation. You don't understand something by looking it up in a giant fixed rulebook. You adjust your understanding constantly based on the specific situation you're in.
So if an AI were built on a hermeneutic model, how would it work differently? Instead of just checking its internal, rigid library catalog. It would need to become aware of the dynamics, the context, and adjust its own understanding for each specific input.
Exactly. It's a fundamental shift. It moves away from just processing raw data, raw symbols. It starts trying to interpret the user's intention, their background, the specifics of that moment.
That sounds like a huge leap from that old physical symbol hypothesis.
It is. But there's an important nuance here about how we interact with AI. When we chat with these systems, we humans naturally start attributing intentions to them, don't we? We think, oh, it's trying to help, or it meant to give me that fact. We adopt what Dennett called the physical design or intentional stance.
Right. We project our own human way of thinking onto the machine.
We do. And our sources emphasize that human projection is not the same as the AI actually performing the interpretation itself. Hermeneutic theory describes the complex, layered, dynamic activity that we do, and that we need the AI to genuinely start doing internally. We need the system to go beyond just syntax and algorithms, which is, how machines understand now, and actually ground its understanding in the world.
Okay, so the philosophy points the way, but it demands a technical fix. We can't just tweak the existing models slightly. The argument seems to be for a bigger shift, a paradigm shift into something called hybrid systems, to fix that context blindness we see now.
Exactly. And this brings us right into the realm of cognitive architecture design. Sources like Vadinsky have explored these hybrid architectures specifically designed for this kind of complexity. A key feature is what they call stratified cognitive schemata.
Stratified cognitive schemata. Okay, break that down. Schemata are like mental frameworks, and stratified means layers.
You got it. Think of schemata as flexible blueprints for how concepts connect. And stratified means they operate on multiple levels of abstraction at the same time. So you need lower levels dealing with concrete, empirical data, what words were just said, what's happening right now. But you also need higher levels dealing with abstract, symbolic reasoning. What's the general concept of banking or justice?
Ah, okay. And the power of these hybrid models comes from combining two approaches that often seem opposed, right? The strict, logical rules of symbolic reasoning with the more fluid, pattern-finding ability of empirical adaptability, like in neural networks.
That's the core idea. They aim to be robust for tasks needing both precision and that crucial contextual understanding. And this specific combination, flexible learning plus structured representation, is key to tackling what might be the biggest hurdle for purely statistical AI, which is the grounding problem.
Okay, the grounding problem. But wait, if we're bringing back symbolic logic, the rule-based stuff, aren't we risking reintroducing that same rigidity we were criticizing earlier? How do these hybrid systems avoid getting stuck in fixed categories again?
That's a really sharp question. And the crucial difference is in the combination and how they interact. Remember, the grounding problem is about connecting the AI's internal symbols to actual meaning in the real world. A purely symbolic system is rigid because its symbols are ungrounded. They just float, disconnected from experience. And a purely neural network is fluid, learns patterns, but it lacks the structured precision to reliably pin down concepts. It can drift.
So the hybrid model acts as the bridge between them.
Precisely. The hybrid approach uses the empirical, adaptable side, the real-world data, the context, to constantly validate and ground the symbols used by the structured reasoning side. And then it takes those grounded, specific experiences and abstracts them, classifies them, so that knowledge can be applied effectively in new, similar situations. It's this constant back and forth, this loop, that aims to bridge the gap between the system's internal mind and the external world without falling back on static, brittle rules.
Okay, this is where it gets really fascinating for me. Because this hybrid architecture, it doesn't just solve a technical problem like grounding. It actually provides the mechanism for continuous learning and improvement, reflecting that core philosophical idea, the hermeneutic circle.
Exactly. The hermeneutic circle is all about dynamism. It's the idea that understanding moves between the specific part and the general whole. And in these hybrid systems, meaning isn't fixed. It's designed to be fluid, evolving. That fits the hermeneutic ideal perfectly. The AI can dynamically adjust its internal world model. It can improve how it interprets things based on who it's interacting with, the context, the history.
Okay, walk me through that cycle. How does the hybrid system actually do the hermeneutic circle? How does it mirror human learning?
Right. Think about interpreting a word again, like bank, in a sentence you just read. The system takes that specific input, the sentence. It processes it using its current understanding. It might realize, in this specific context, given the surrounding words about money, bank means a financial place, not the edge of a river.
Like,
So that specific interpretation is used to refine its general knowledge. It abstracts that finding.
and then what happens with that refined general knowledge?
That updated higher-level understanding of this slightly adjusted probability that bank means finance in text like this is then applied when it encounters the next specific piece of data. It creates this continuous, potentially unending loop. Interpreting the specific detail refines the general rules or understanding, and those refined general rules then improve the interpretation of the next specific detail.
So interpretation constantly leads to adjusting the AI's internal rules, its data, which improves its overall knowledge base. It's like an active cycle of learning, refining, understanding better next time, just like we do, ideally.
Exactly, and that connects interpretation and knowledge, or epistemology, beautifully. If epistemology is about the state of knowing what knowledge we hold, then hermeneutics is about the state of interpreting the process of how we come to know. Interpretation becomes the engine, the representation of how knowing happens and evolves. It links the what's of knowledge to the how of understanding.
Okay, let's bring this home for the listener. We started with that common frustration, the chatbot that sounds smart but misses the point, stuck in rigid, static ways of thinking. And we've traced this path, guided by philosophical hermeneutics, towards designing AI differently, towards dynamic, context-sensitive hybrid systems that try to mirror the fluid, evolving way humans actually understand the world.
And it's crucial to see this isn't just a one-way street with philosophy helping AI. It's reciprocal. As AI advances towards genuine meaning awareness, it actually pushes back on philosophy. It challenges philosophical hermeneutics itself. Think about it. If AI starts creating art, say, that people find more compelling than human art, well, that forces philosophy to seriously re-examine what we even mean by terms like interpretation, understanding, maybe even creativity.
That's a fascinating feedback loop. Philosophy informs AI design, and advanced AI forces philosophy to refine its own concepts. And this whole collective effort trying to connect context and knowledge, aiming for something like human understanding, it operates within this broader field people are calling Sophimatics.
Right. Sophimatics kind of captures this ongoing dynamic relationship, the constant effort to figure out and build the principles of knowledge and intelligence, whether it's in us or in machines. It really underscores that the quest for genuinely understanding AI and perhaps understanding ourselves is never really finished. It's not static.
Which leaves you, our listener, with maybe a final thought to chew on. If the engine of real intelligence, the kind that truly understands, relies on this unending hermeneutic circle, this constant cycle where interpretation has to keep adjusting and redefining knowledge, can we either in philosophy or in AI research ever actually arrive at a final, fixed, static definition of what understanding truly means? Or is the very nature of understanding itself always going to be, well, in flux?